Right, so we're gonna go live. So it is lab time. Oh, lab time now. So we're going to listen to three videos, three or so videos. Listen to them carefully because the information that is there is important. All right, so we cannot be in the lab physically, but we can be in the lab virtually. So here we are in our lab. And these videos are not, they were not created by CDP National Services. We just went on YouTube and I saw some appropriate videos that benefit us greatly. So thanks to those persons who had created these videos. So this one is about the reaction of calcium and water. So we're gonna watch it 2 or 3 times and make notes the second and third time.
If we go down the column in group 2 from magnesium to calcium, we see that the calcium is also stored in the air. Instead of being a shiny metal, the calcium is coated with a layer of the metal oxide. As you go down the column in group 2, the metals tend to get harder. Calcium is malleable, but requires a great deal more force to shape it. Calcium is a metal and does conduct electricity. If we add the calcium metal to water, we get a much more rapid reaction of the calcium with the water than the magnesium. The reaction is very exothermic. This is due to the lower ionization energy of the calcium. We get a single displacement reaction producing hydrogen gas and the formation of slightly soluble calcium hydroxide. We can test for the hydrogen gas by collecting some of the hydrogen gas in a test tube and testing its flammability. We can test for the presence of calcium hydroxide by adding phenolphthalein indicator. The indicator turns purple, indicating that the solution is basic and that calcium hydroxide has been formed.
All right, so we're gonna watch it a second time. Good. Now, this gentleman is inside of a chemistry lab. Good. And you'd have noticed, by the way, before I tell you what I noticed, can anyone tell what they observed from the first watching of the video? What you observed? Not about what you saw, what you heard. What you observed. Not what you saw or what you heard. What did you observe? Anybody? What you saw, what you observed. Anybody? Anybody? Kadeen? Makeda? Kadeen, are you there?
Yes, sir.
You heard me ask a question a while ago?
Sir, could you replay it?
Okay. All right.
Could
I'll
you?
replay it.
Yes, sir.
Okay. Kim Maxwell. I don't know if Kim Maxwell is Makeda. Please let me know if it's you, Makeda. All right. I think Makeda, if it's Makeda that, is saying that she observed that he was hitting a metal thing and he said it was calcium. Okay, all right. So I'm going to play it again. So please note what the video is about. It's about a group 2 metal. And it's referring to physical properties of calcium and its reaction with water. So this video is about the physical properties of calcium and its reaction with water. Last week, we looked at the physical properties of magnesium and its reaction with water. And you need to listen out for 2 keywords: ionization and reactivity. Ionization and reactivity. Last week's class, we learned that if the metal ionization level is high, its reactivity level will be low. We also learned that, so well, the opposite is true, that if the ionization level is low, the reactivity level will be much higher. All right? So listen keenly now to what the gentleman is saying.
If we go down the column in group 2, from magnesium to calcium, we see that the calcium is also stored in the air. Instead of being a shiny metal, the calcium is coated with a layer of the metal oxide. As you go down the column in group 2, the metals tend to get harder.
So note what he said. Now last week, we looked at magnesium. The magnesium is also a group 2 metal. I don't know if you wrote it. Use back your notes again, Kadeen, if you have it in front of you. What is that? What do we use to determine if an element, what do we use to determine the group of an element? Which group the element is in? We did this in previous class. What do we use to determine?
I wasn't at the previous class.
Yeah, man, you were at the first, but you were at the class when we first looked at it. So you should have written it in the notes.
First class.
You were at the class. The first time we looked at group and period, you and Brittany was in the class. Yeah, so you were in the class. You don't make notes. You don't make notes. Huh?
I don't recall that. I only recall about the periodic table and the periodicity.
So didn't we draw shells and we ask, like for example, the number of electrons in the last shell give us a group number? You weren't in that class?
Oh, yes.
Oh, so you didn't write the notes for that one then?
No, I didn't get to write that part.
Let me tell you something, Kadeen. Exam expensive. Very expensive. As I look at the paper, the exam for one single subject alone is $10,485. For 2 subjects, $14,445. And the list goes on. Every year increases. Cannot waste time, cannot waste money. Don't make it up now again, okay, sir?
Okay, sir.
So if you intend to spend money to pay for this exam and for the class, make the best use of it. Make the best use of it. Now, when you're going to determine which group an atom is or an element is in, you will draw the structure. You will draw the atomic structure. You draw the atomic structure. And when you draw the atomic structure, you put on the electrons. The group number is determined by the number of electrons in the last shell, the number of electrons in the last shell. Hope you're writing that down.
Repeat, sir.
To determine the group number of an element, you use the number of electrons in the last shell. Use the number of electrons in the last shell. All right. To determine the group number of an element. You use the number of electrons in the last shell. Information number 2. To determine the period number of an element, you count the number of shells. Count the number of shells. And that number of shells will tell you the period number. All right? So you need to know those two things. Now, so based on what this gentleman was saying, magnesium, what is the atomic number for magnesium? What's the atomic number for magnesium? What's the atomic number for magnesium?
I don't know, sir.
So you never do the assignment? Don't ask which
Didn't
assignment.
understand
Don't
the
ask,
assignment, sir.
don't ask which assignment. Sir. So you never understand the assignment. What were you supposed to do? What was the assignment, by the way? What was the assignment you were supposed to do?
Define the first 20 elements
And do what?
and
And do what?
define the first 20 elements and to must find what they are made, what they made.
Did you write down the assignment? Did you write down what the assignment was about?
Make models of the first 20 elements.
Okay. So you say you didn't do that at all?
I did understand, sir.
So did you try?
Repeat.
So did you try?
No, sir, but I reach out for your help and
No.
said,
Did you hold on? Ah, Kadeem, I'll tell you something now. You want to pass this exam, young man?
yes, sir.
You're sure?
Yes, sir, I'm sure.
So hear me now. You're cut out the foolishness. You're going to cut out the foolishness. Otherwise, if you plan to form the fool of yourself, I'm going to allow you to form the fool of yourself and you will fail the exam. Is that what you want, sir?
No, sir.
Well, you're going to have to come differently. You have to go roll up a sleeve and come differently. And I'm serious. No, you never. So what? So you missed last class. You never do the assignment. What is that? And I demonstrated what I wanted in the class. So you never understand. By the way, if you want to know the atomic numbers of each element, what you need to look at, you already find the atomic numbers. What you need to look at.
Find
What
your
did I,
atomic.
huh? Come again?
No, you were saying something.
No. Uh, last year and the year before, I got 100% pass in chemistry. And I get angry when students come to me with irresponsible behavior and nonsense. Right now, we are doing that. Make today be the last day. You're going to be irresponsible. Okay, sir? Okay, sir.
Yes, sir.
So it's the next class. You are going to find the first 20 elements of the atomic structure. And you're going to write down their atomic numbers. And you're going to draw each of them. And you're going to present that in the next class. Okay, sir?
Yes, sir.
All right. Let's continue the class.
Calcium is malleable, but requires a great deal more force to shape it. Calcium is a metal.
Now, let's get back to this.
If we go down the column in group 2, from magnesium to calcium, we see that the calcium is also stored in the air.
Now, notice it says, when you go down from the column, along the column for group 2, and we're going to look at the periodic table again. One last time. You're going to look on it here. You must have a copy of the periodic table in your notebook. You should have a copy of the periodic table in your notebook. So let's look at the periodic table first. Here's the periodic table. And as it says, you go down the column of the periodic table. That's what it's basically saying. So you have magnesium before calcium. And he just said that as you go down the column of the periodic table, the material, the element becomes more all right, my mic was sorry about that. You were hearing me a while ago. check, my check, my check. My check 1, 2, 3. Just testing my check 1, 2, 3, check. My check 1, 2, 3, check. My check 1, 2, 3, check. Units. My check 1, 2, 3, check. My check 1, 2, 3. Are you hearing me now?
Yes, I'm hearing you.
Okay. All right. So what we're saying is that this is a periodic table that we're looking at. And in the video, he just stated that coming down the column, the metals get more harder, good, malleable. Now, so magnesium is softer than calcium. As you go further down, the metals get more harder. However, all these metals right here are in group 2, which suggests that they have 2 electrons on the last shell. However, calcium and magnesium is in different periods. So let's make note of it. The groups run vertically. The periods run horizontally. Got that? You got that?
Repeat, please.
I am saying the groups runs vertically. You got that? You got that? You got that, yes or no?
Yes, sir.
And I said no, that the period runs horizontally. So period 1, period 2, period 3, period 4, and list goes on. You got that?
Yes, sir.
No. So calcium is in period 4 and magnesium is in period 3. So we probably could say that the lower the period or the higher the period of the element is, the more harder it is. Good? All right. So let us look at the characteristics of calcium some more. They will compare them, both magnesium and calcium. Just get back to the video.
Here. Instead of being a shiny metal, the calcium is coated with a layer of the metal oxide. As you go down the column in group 2, the metals tend to get harder. Calcium is malleable, but requires a great deal more force to shape it. Calcium is a metal and does conduct electricity. If we add the calcium,
and I just wanted to observe too that chemistry is real, nothing false, right? And in studying the properties, they're looking at what they're able to do, the different characteristics of it. So we notice that it is hard in nature. And you observe a while ago that the calcium is also, even though it's hard in nature, it can also conduct electricity. Good. Calcium, you might be saying, is this the same calcium that is in milk? Yes. But it can come in different forms, right? And we learn more about that in the future.
Metal to water, we get a much more rapid reaction of the calcium with the water than the magnesium. The reaction is very exothermic. This is due to the lower ionization energy of the calcium. We get a single displacement reaction.
Note he's saying that the calcium has a lower ionization. And I said to you earlier that if the ionization is high, then the reactivity will be low. Good? Because when in last week's lesson, when magnesium was placed in water, it never reacted at all. It started to react when we use heat. So heat had to be the catalyst to speed up the reaction. But here we see that calcium has a lower ionization level, and hence it reacts much aggressive, rapidly with water. Therefore, where you can probably store magnesium in water in a cool environment, you cannot store calcium in water and don't expect it to carry out a chemical reaction. Understand that? Understand that?
Yes, sir.
Okay. Let's continue.
Producing hydrogen gas and the formation of slightly soluble calcium hydroxide. We can test for the hydrogen gas by collecting some of the hydrogen gas in a
which gas is he testing for here?
Hydrogen.
Okay.
test tube and testing its flammability. We can test.
What did you hear a while ago?
I heard a pop.
Good. It's very important to know that because you have exam questions based on that. What is described the test that is used to test for hydrogen. So you look for a pop sound. Good, pop sound. So the test for hydrogen is when you collect the gas, put it over a flame, and you should hear a pop sound. Once you hear a pop sound, it means that hydrogen gas is present. I hope you're making notes of that. We're making notes of that. Right. No. All right. So you make note of that, right?
Repeat, sir.
Make note of that. You made note of that a while ago, right?
I couldn't hear clearly.
So if I never ask if you make note of it, can you have to repeat? Let's go. All right. I said that you may be asked to describe hydrogen test. So in describing the hydrogen test, you have to mention the fact that you have to first collect the gas in a test tube, place it over a flame, and listen for a pop sound. Got that now?
Yes, sir.
Test for the presence of calcium hydroxide by adding phenolphthalein indicator. The indicator turns purple, indicating that the solution is basic and that calcium hydroxide has been formed.
So He's telling the solution is basic. What it means, it's alkaline as well. Good. And so you can see here we have a equation. Good. We have an equation. And we learn later on in the lesson about this equation. Now, calcium plus water were the reagents. Water and calcium. And note what you just saw in the lab is what is written right here using the chemical formulas. So when we reach this part of the lesson, the class, coming classes, you can't miss them, and not all the classes will be streamed. Some will be streamed privately, and some will be streamed publicly. Not all will be streamed publicly. Now, some will be streamed privately. Therefore, I have to use an email address for you to see that class. All right. Now, so the chemical formula is used here to express or describe, and this is how we describe chemical reactions in chemistry, using chemical formulas. And that's why it's important, Kadir, that you did that first assignment. That is the rock of chemistry. So you have to do the assignment. You understand that, boss? Do you understand that?
Understand.
All right. Don't come back to the class and tell me, sir, I'm going to do the assignment too. All right. So calcium solid, water liquid. And what was formed here is calcium hydroxide. Good. And hydrogen gas. So these are the products of the chemical reaction. So we have the reagents, and we have the products. The products were calcium hydroxide, which we tested using the substance, and the calcium hydroxide turned that from white to pink. And then you test for the hydrogen gas with a pop sound. All right. Good. I'm just going to look for another video. We'll look at another video now, which is repeat. It's a repeat of what was done here. So.
I'm now going to demonstrate the reaction of calcium metal and dilute hydrochloric acid. The hydrochloric acid I'm using on this occasion is 0.5 molar. And I'm just going to put a small chip of calcium metal into the...
And notice the characteristics of the... Oh, can you describe the hydrogen chloric acid? Just by using the eyes. What can you say about the hydrogen chloric acid just by using the eyes?
It's clear.
It's clear. All right. What's another word for it we could use?
Transparent.
Transparent. Another word. Colorless. Right? Clear, transparent, colorless. All right. Clear, transparent, colorless. So when you write in a response for the chemistry exam, you must be able to use words such as such to describe. All right. And if you see the word used in the question, you must be able to recognize, have an idea what they're really talking about. So very important. All right, before going further in the video, what you're seeing right here, wood material, is called a test tube rock. So this is a test tube with the hydrochloric acid inside of it. And then we have the test tube rock. And yes, same hydrochloric acid that comes from the stomach. Other things to think about, right? Yes.
The acid and watch what happens. So very quickly we get the evolution of hydrogen gas bubbles, and also we're getting the formation of calcium chloride, which is dissolved in the aqueous solution. The reaction is quite vigorous, as you can see. It's important not to do this reaction with very strong hydrochloric acid, because what can happen is, as the reaction is very exothermic, you can get the content shooting out of the tube very easily. And the calcium metal has just about finished reacting there. Remember, we're making bubbles of hydrogen gas, and calcium chloride is dissolved in the aqueous solution.
All right. So here's a second video. And a similar way in which calcium reacts with water, it reacts with hydrochloric acid. And again, the same gas is given off, hydrogen. So hydrogen is given off, was replaced by, if you look right here, this is hydrochloric acid, but the hydrogen was replaced by the calcium, and it was given off as a gas. Good, that's what the chemical formula is saying. So calcium was added to hydrochloric acid. The calcium replaced the hydrogen, and the hydrogen gas was given off. And then calcium chloride was formed. It's a salt, right? So the acid and metals create salts. But make note of that. That will come back again, but you can make note of it now that acid plus metals give you salts. All right. Now, so as we go further, what we're looking at, what you must take from these two videos is that the higher the reactivity level, the lower the ionization level. The higher the ionization level, the lower the reactivity level. What? And you have labs right there. So our last lab now, last video. This one now is magnesium in hydrochloric acid. Let's see what happens with the magnesium in the hydrochloric acid. Just give me. So here we are in this video, right? Let's go.
So first you sand a magnesium ribbon to get rid of the magnesium oxide layer, so then the magnesium can react.
So know what she said, to remove now, because the magnesium was exposed to air. Air meaning oxygen. It formed magnesium oxide. Good. So note that magnesium oxide can be formed when exposed to air or oxygen, right? So they are removing the oxide from it so that it can do its thing, all right? You got that, Kadeen?
Sir, I wasn't hearing it clear. Could you repeat, please?
What I was saying is that you heard she mentioned magnesium oxide. You heard she mentioned magnesium oxide. You hear me clearly now?
Yes, sir.
So she was mentioning magnesium oxide. And how to get the magnesium oxide is because the magnesium was exposed to air. Air meaning oxygen. Good. So oxides is when metals react with oxygen. Good. So they are rubbing it off to remove that part of it. All right.
React with hydrochloric acid.
It's very low, so I'm not hearing what she's saying.
And then you weigh the magnesium ribbon. And then you cut a piece of the copper wire and wrap it around the magnesium ribbon to secure the ribbon inside the test tube. Fill the test tube all the way with water. Seal the
So note, the magnesium metal or ribbon is a test tube of water. Right? You hear me clearly?
Could you start over, please?
Why are you not hearing me clearly? What does that mean on your side? You have noise in the background?
No, the internet is kind of giving a bit of trouble.
Okay. All right, what I'm saying is that if you notice, she had added the magnesium in a test tube of water. And in this case, you recognize it's not reacting really in the test tube of water. Unlike when the calcium went into water, it started to react. Good? So note that difference.
test tube with a piece of parafilm to keep the magnesium and water inside when you invert it in the hydrochloric acid. Pour hydrochloric acid in the beaker. Invert the test tube into the hydrochloric acid and get rid of the parafilm so the hydrochloric acid can react with the magnesium. When the reaction has completed, mark the water level. Test for hydrogen gas. Fill the test tube with water until the marked line. Pour the water in the test tube into a measuring cylinder to measure the volume of gas produced in the reaction.
All right. So once again, you see how the test for hydrogen, for hydrogen itself. So that you should not forget that test at all. You see it twice. You have heard it to their ears. So hopefully you'll not forget it. And of course, you'd have realized that with the acid, the magnesium reacted much quicker with hydrochloric acid than in water. All right? Okay. So you understand all that now? You understood all of that? Understood everything there, sir?
Not 100%, but I'm getting there.
What is the what part you don't understand? What part you don't understand?
Well, um, it's kind of difficult to know the mixture and so on, but I'm getting there.
To know what mixture? The only thing you need to know, make note of, is the properties of the calcium and the magnesium. One, magnesium is much more harder than, sorry, much more softer than calcium, while calcium is much more harder than magnesium. You got that? Understand that?
Yes, sir.
And calcium reacts much faster with water, and magnesium does not react with water naturally. Got that too?
Yes, I did.
You understand that clearly now?
Yes, sir.
Both magnesium and calcium are conductors of electricity, means that you can put it, it can work like a battery. Understand that now?
Understood.
Okay, that's the aim of this. And then of course, both, and when they react with acids, hydrochloric acids, hydrogen gas is given off. When both group 2 elements, magnesium and calcium, reacts with or combines with hydrochloric acid, a salt is formed and a gas is formed, and the name of the gas is, what's the name of the gas? What's the name of the gas?
Repeat, sir.
What is the name of the gas given off?
Hydrogen.
Hydrogen. How is the hydrogen tested?
Um, There. You put it over a flame and you hit listen for a pop.
That's exactly it. Do you understand clearly now?
Yes, sir.
Okay. All right, we can move on. All right. So this is going to be our place to write this down. Very important. This is the main part of the lesson. Ionic bonding and covalent bonding. Write them down for me, please. Ionic bonding and covalent bonding. If you want to draw what's on the screen, you can draw it. You heard that? You heard me?
Yes, sir.
Okay. When you finish drawing what's there, let me know, please.
Repeat.
When you finish drawing what you see on the screen, when you finish drawing what you see on the screen,
Yes.
let me know when you finish drawing it.
Okay, will do.
Mm. Finish drawing it now. Finish drawing it now.
No, almost finished though.
Okay. Finish now.
Yes, I'm finished.
All right, quickly. All right, so this picture is showing us ionic bond. So you have a metal and it is transferring one electron to a non-metal and therefore forms an ionic molecule. You get that?
Repeat, please.
I'm saying this picture here is showing that this atom transfers an electron to a non-metal and the result is an ionic molecule. So the one that gave up an electron became positively charged and the one that received an electron became negatively charged. You get that?
Yes, sir.
In this diagram here, this is just a repetition of the first one, but just a different expression of it. So once again, we see one atom giving up an electron to another atom, and that is called a transfer of electrons. Good. So one lost, one gain. One lost, one gain. Got that? Got that?
Sir,
Okay. So the one that lost became a positive ion, and the one that gained became a negative ion. That is ionic bonding. So ionic bonding involves metal and what? Metal element.
Non-metal.
Good. And what else does ionic bonding involves? Based on the picture they're looking at.
In the ionic molecule.
What action took place?
Turning metal into non-metal.
See there, man. Transfer of electrons. You see it?
Yes, I see.
So when you are describing ionic bonding, you have to use the phrase transfer of electrons, where one atom loses an electron, transfers it to another atom which gains the electron. You see that now? You see that?
Yes, sir.
Okay, so I've made note of these things. The last picture here now, we see sodium atom. Now the atomic number, you see why? All right, you see why it is important now to create the models then for the first 20 elements. You see why it is important? Because it will run through the rest of the chemistry program. You get it now? You see why it's important now? Boss,
Yes, sir.
this is why it is important. Understand why now?
Yes, sir.
Okay. So the sodium atom has 11 electrons. 2 on the first shell, 8 on the second shell, 1, 2, 3, 4, 5, 6, 7, 8, and 1 on the last shell. Based on what I told you earlier, which group is sodium in? Which group is sodium in? Which group is sodium in? Kadeen.
On the
Huh?
last line.
Which group is sodium in? Let me see if I write down the notes when we get since in the class here. Again, I write down the notes. Did you write down the notes, Kadeen? You wrote down the notes?
I
Huh?
did.
So, did you write down the notes? Yes or no?
Yes, sir.
You wrote down the notes? Yes or no?
Yes.
So, use by the notes that speaks about group number. Which group is sodium in? It has 1 electron on the last shell. Which group is sodium in? Which group is sodium in, Kadeen?
One moment, please. Sir, the line inside with the 8 on it.
Yeah, but which group is it in? Which group is it in? I
2.
told you. Huh? Which group?
2.
Oh, you get group 2. Read what
On
you
the
said.
line.
Read the information about group number that you wrote down. Let me hear it. What you wrote down. Read that, let me know what you wrote down. Read and tell me what you wrote down.
The number of electrons on the last shell of the atom.
Oh, so how many electrons is on the last shell for sodium?
1.
So which group is it in there?
Group
Group what?
3.
Read what you just wrote a while ago. Read it again, let me hear it.
The number of electrons on the last shell atom
Is equal to the group number.
is equal to the group number.
So you never write down the partner then. So put that. You write down that part now?
Is equal to the group number.
So what group is sodium in there? What group is sodium in?
1.
1. Good. At least I get it. All right. So that 1 electron that it has, it's going to give it up and become a positive ion. And you see sodium ion being positive. Good. Now, before chlorine received an atom, an electron rather from sodium, what group is sodium, is chlorine in before it receive an electron from sodium? What group is chlorine in? What group is chlorine in? You heard the question, Kadeen?
No, sir.
What group is chlorine in? Look at the picture and tell me what group is chlorine in before it received this electron. So don't count this electron in it. Don't count the white one in it. So what group is chlorine in?
I'd say 3.
Huh?
3.
We get 3. Read the notes and follow the notes. Kadeen, read the notes and follow the notes. Read the notes and follow the notes, young man.
Repeat the question, please.
What group is chlorine in?
Group 1.
Read the notes and follow the notes. What the notes say a while ago about group number.
The number of electrons on the last shell of atoms equals group number.
So what should you do to know the number of electrons on the last shell? What should you do?
I believe count them.
You believe count them or you should count them? Which is it? You
Count
must
them.
count them, Kadeen. Come on, man. Use your common sense, man. Come on. So count them and tell me. Which group is it in?
7.
You need to do that. You need to do that presentation. You need to do that presentation. And if you're not ready for the presentation for next week, don't bother coming to class. So be prepared. You have 1 week to be prepared. You understand that? You understand that?
Understood.
Okay. No. So it is moving from here to here. So now the last shell now has 8 electrons. So it becomes stable. And therefore, we end up with sodium chloride, which is an ionic molecule. So that is ionic bonding for you. And this is it for today. And young man, you need to follow instructions. It's impossible for you to pass. But if you don't do what you're supposed to do, you are not going to do well. You have to do what you're supposed to do. Make the effort. Make the effort. If you don't put in, you're not going to get out. Do you understand that?
Understood.
We'll show that you understand by next week. That's it for tonight, sir. Have yourselves a good night. That's it.
Good night.
Okay, sir. You may click and leave. Now, for those persons who are viewing this live on our CDP Labs Data Services channel, I know that I was being very hard, but students must understand that when you receive assignments, you must do the assignments. The assignments helps to establish your understanding, provides you with knowledge that when you come to classes, you can use the knowledge gained to respond to questions asked. And then you will fortify your understanding. If you make an effort, then the teacher can complement that effort. And so you can improve and become better, that you can perform. So yes, last year we did HSB and we got 100% pass. We got 100% pass in chemistry, even though we didn't stream it. But listen carefully. Those who might be hoping to see another chemistry lesson or the continuation of this chemistry lesson. If you want to see this chemistry lesson, be a part of this chemistry class, why not register with CDP Labs Data Services? Just go to our website, www.cdplabsdataservices.com, because we will not be streaming the continuation of this lesson. It will be streamed, but not publicly, but privately, only for registered students of CDP Labs Edu Services. As of January, for sure, we will be going live throughout like earlier this year, when we came on the live in January, we will go live, but maybe 2 classes, not all the classes. And we offer human and social biology, we offer straight biology, we offer chemistry, physics, principles of business, English language, and more. Coming soon to CDP Labs Data Services is accounting clerk. You can do your art certification with us. We will prepare for the art certification, I should say. So you can be an accounting clerk at an organization that needs accounting clerks. So that is coming soon. And we'll let you know when it is coming, but you can start applying for that program as well. You'll be informed when the website is ready to receive applications for those programs. So thank you for viewing, and hope you register with CDP Labs, the home of grade 1 students. Thank you.